In this video, I'm going to start with the definition of logarithms and work some examples. Remember, the reason for this channel is to help you pass your math class so you can get to your goals and get a better life. Logarithms coming right up. So I want you to say this to yourself. A logarithm is an exponent. Say it. A logarithm is an exponent. So that means in this first example, log base 4 to the 64 equals 3. Since 4, which is the base of the logarithm, 4 to the power 3, notice how the logarithm is the exponent, equals 64, the argument of the function. 64 is called the argument of the function. And of course, the base here is base 4. Base 4. A logarithm is an exponent. So in this case, this is going to be minus 3, since 3 to the power minus 3, well, that's going to equal 1 over 3 cubed, or 1 over 27. A logarithm is an exponent. Next, we're given a logarithmic equation we need to solve, and we have to use the definition. The base is 2. A logarithm is an exponent, so it's 2 to the power 5, equals the argument of the function, which is x plus 4. And that's just from the definition. And once we've done that, it's quite easy to solve this now. 2 to the power 5 is 32. And that equals x plus 4. Subtract 4 from both sides, and I see that x equals 28. Let's talk about the two definitions for the standard kind of logarithms we see on a calculator. If you see log x with no base shown, then that is a common logarithm, and the assumed base is 10. When you see ln x, then that is the natural logarithm, and the assumed base is e. Remember, e is 2.718, etc., etc., for all x greater than 0. So let's work out the first problem. By the definition, I know I have base 10, and a logarithm is an exponent, so it's base 10 to the 0.265 equals the argument of the function, which is x. And I can calculate that on my calculator. I'm likely going to have to do an approximation. So 10 to the power 0.265, and that's going to give me 1.84077, etc. So I'm going to round that off. I'm going to say that's approximately 1.84077. And now I want to check it. I'm going to put it in the calculator, and I'm going to check. In fact, I'm going to use the log key on the calculator. So I'm going to calculate log 1.84077, and I expect to get pretty close to 0.265. Let's see what that is. So here's the log key, and 1.84077. And that gives me pretty darn close to 0.265. It's not exactly. Obviously, the more decimal places I have, the closer I'll get to 0.265. And that's my first problem. Let's do the problem B next. And we're going to use the same approach to solve this problem. We will need to think about the definition here. So we have e, logarithm is an exponent, to the power 4.2 equals x. And let's put that into the calculator. That's going to be an approximation too, of course. So here we're going to have to use the second key, e to the 4.2 power, enter. And that's going to give us about 66.68633. So you could choose more or less decimal places. 66.68633. Again, I can check this one. If I put in that ln, and I said x is 66.68 663, so I'm going to just approximate that. So 66.69. So I've rounded it off, so I expect to get a rounding error here. So the natural log of 66.69, and that's going to give me 4.2, approximately 4.2. So that confirms the solution to my problem using the definition of logarithms. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.